on the dilution equation. To start, let's do a familiar example of a dilution. If you go to the grocery store, you can buy concentrated cans of juice, like orange juice, and you make the orange juice drinkable by diluting it. I would buy this can from the grocery store, which contains concentrated juice. I would pour it into a pitcher, and then I would fill the can up 3 more times with water and add those to the concentrated juice to make the final diluted orange juice. When I do this, I start out with a more concentrated juice solution and I make a less concentrated juice solution. Today, we're going to talk about the relationship between the volume and concentration of the original, more concentrated solution and the volume and concentration of the more diluted solution. We will be using the dilution equation to talk about the two relationships here. C1 is the first concentration and V1 is the initial volume. Here we go, we're talking about this solution. The initial concentration and the volume of this solution multiplied together will end up being the same value as the concentration of the new solution times the volume of the new solution. So these two quantities are related and they are equivalent. So if we know how much orange juice we started with and we know the initial concentration, if we also know the final volume, we can find the final concentration. Let's demonstrate how this is true using the first two questions on your activity. The first question is a review on concentration units. It's asking you to find the percent sugar in m/v. So we know that the percent sugar in m/v is just the percent in grams per milliliter. We'll put solute on the top and the volume of the solution on the bottom, and then we simply need to multiply by 100% to get it in percent. We need to report this value in two significant figures, and so we would round down to 12%. This is the initial concentration of sugar in the concentrated orange juice solution. And the next question will ask you to find the concentration of the sugars in the more dilute solution, or the final solution when you add water. It's a good idea to keep track of initial and final concentrations and volumes, like this. In this case, C1 is the initial concentration of the orange juice. We just said that this was 12% m/v sugar. The initial volume is 240 milliliters because that's the volume of 1 can. The concentration of the final solution is unknown. This is the value that we will try to find using this equation. The final volume is the total final volume of the solution. Since we added 1 can of orange juice with 3 additional cans of water, the final volume of the solution is going to be equal to 4 cans, which is the same as 960 milliliters of solution. Now we have 3 of the variables, and the 4th one is unknown. This allows us to solve for the final concentration. I pay attention to the units the entire time through this calculation, and that allows me to determine what the concentration units of my C2 variable are. Notice that in this equation, milliliters cancels because it's in both the numerator and the denominator, and so my final concentration here will end up being in units of percent m/v. My final answer will be given in 2 significant figures. The value is 3.0 and the units are percent mass over volume. This equation will be used all of the time in a medical setting because one of the most common tasks you will have as a nurse is to dilute medicines before you administer them to patients. Here are some pictures of medication labels. All of these medications must be diluted before administering them to patients. Notice that this one, for example, is labeled as the concentrated solution, and it tells you that it must be diluted prior to IV administration. Sometimes when you get a medicine, you'll also get an instruction manual, and it will tell you exactly how to dilute the medicine, step by step. But sometimes the medication will not come with an instruction manual, and you'll be expected to know how to dilute it to get the final and correct concentration to give to your patients. This can be very easy once you get the hang of it. but it can also be very tricky. For this entire activity, we're only going to practice using this equation, C1V1 equals C2V2. Let me give you one example of the way that you'll want to use this. I'm going to start out with a solution that has some red dye in it. And I'll say that the solution is 25% V over V. So it's 25% solution of red dye. To start, I have 200 milliliters of the red solution. I'm going to dilute it by putting 5 milliliters of my red solution and combining it with 25 milliliters of water. Pause the video now and decide what is your first concentration and your first volume and the second concentration and second volume that you would use in this dilution equation. Now let's see if you're right. Concentration 1 is referring to the first solution. And so the concentration I gave you was 25%. Now the first volume that I'll use is the volume that I actually used to make the new solution. This is not 200 milliliters. In fact, it doesn't matter how much red solution I started with. It only matters how much of the red solution I added to make the final diluted solution. In this case, I used 5 milliliters of my initial concentrated solution. I diluted to a final volume of 30 milliliters. When I combine 5 milliliters of the red solution and 25 milliliters of water, my final volume will be 30 milliliters. The concentration of the final solution is what I can find with the dilution equation. The most common mistake is to use the wrong information in this equation. For the rest of this activity, please practice applying this equation to solve the problems. Please check the key to make sure you're correct. Thanks for watching this video on the dilution equation. If you have any questions, feel free to post them in the comments section, and please vote and let me know if this video was helpful.